Hello dear friends. When I was going through some of those questions that were set by Chinese University entrance examination, guys, I came across this particular question and it triggered my attention. So friends, we shall be looking at the solution to this particular question. Stick around this video, guys, watch till the end so that you won't miss out on any part of this video. So friends, if you look at these questions well, you might feel terrified, not so, but friends, we shall be breaking it down bit by bit. Now we have a couple of e's, right? We have e raised to the power x squared plus 1. On the right hand side, friends, we don't have that. So let's go ahead to clear one of the e's. Note that the only known function that we know that has the ability to take away an e function is simply the natural log function. So if you take the natural log on both sides, we have a natural log of the left hand side equals natural log of the right hand side. If we apply the property of the natural log function that we know by carrying e raised to the power x squared plus 1 to the front, we are going to have what, guys? We are going to have just e raised to the power x squared plus 1, because friends, the natural log of e is simply 1. Then x to the power negative 2 comes in front as well. So friends, in this case, you discover that we have x to the power negative 2, right, and we have x squared. So it's a good hint for us to multiply this entire equation by x squared. If we do that, we have x squared e raised to the power x squared plus 1, which is equal to natural log of 2. Great, guys. So friends, you notice that two things are involved. There are two things involved in this particular solution. It is either we produce an x squared plus 1 here, or we remove this plus 1 here and have just x squared. Which one is easy, friends? Of course, the easiest one to do is to remove this plus 1 here, right? But let's recall that this our x squared e raised to the power x squared plus 1 can be written as x squared e raised to the power x squared multiplying e raised to the power 1. So at this point now, if we multiply both sides by e raised to the power negative 1, you're going to have x squared e raised to the power x squared equals e raised to the power negative 1 ln 2. So at this point now, friends, you notice that since we have x squared e raised to the power x squared here, this is a good hint, friends, for us to use the Lambert W function. So if we take the Lambert W on both sides, we have W of x squared e raised to the power x squared, which is equal to W of e raised to the power negative 1 ln 2. So at this point now, guys, you notice that the output of the left hand side simply becomes x squared, which is equal to W of the right hand side. So at this point now, friends, we take the square root on both sides. We have x to be equal to plus or minus the square root of W e raised to the power negative 1 ln 2. Okay, guys, important hints. You notice that initially this is the function that we have, right? Now, friends, I want you to judge, is this function an even function or an odd function? What do you think, guys? What do you think? What do you think, guys? Of course, this is an even function, right? And as such, we know that the graph of even functions are what, guys, are symmetrical about the y-axis, right? So in this case now, friends, we expect to see two solutions. Why? Because these two curves intersect each other at two distinct points, which those points are equal in magnitude. So in such a case now, friends, we expect to see two solutions. That's why it results in an x equal to plus or minus this, right? So guys, of course, this is the answer to this particular question. Just this exact answer in this form was enough to answer this question on the Olympia. Wait, so guys, that's it. But friends, I know you'll be wondering if I'm going to leave the answer like this. Guys, of course, I love you guys so much, so I'll always give you guys a decimal approximation for that. So if you go to Wolfram Alpha, guys, Wolfram Alpha, and you simply input this your result, Wolfram Alpha is going to give you a value of about 0.4552597 Great. So guys, that's the answer, that's the result. So guys, if you want to see more content like this, friends, make sure you subscribe to this channel, friends, and give the video a like, friends, because just a simple like on this video motivates me enough to keep producing more great content for you guys. Please make sure you let me know which country you're watching this video from by simply posting it in the comment section down below, guys. Just put your country down, let me know which country you're watching from and which university you are. Have a blessed day, friends.